It is past 4, so I'd like to start the webinar. Thank you everybody for joining us today, and welcome to the Access to Space for All HyperGES webinar. So before we begin, I'd like to start off with some housekeeping rules. First, we will have a Q&A session at the end, but whenever you have questions, please use the chat box. Please feel free to write questions at any time in the webinar. So please use the chat box to ask any questions. Second, please answer our questionnaire form that we will be putting in the chat box later on. My colleague Wembin will be very active in the chat, as you can see there already. He will be providing you with useful links and also the link to our questionnaire form. We would really like to hear your feedback on our webinar, so please make sure to answer our questionnaire before you leave. And last but not least, if you are on social media, please use the hashtag Access to Space for All and HyperGES to help us promote this webinar. We are active on Twitter, Instagram, Facebook, and LinkedIn at UNOOSA. Today's agenda looks like this. We will start off with the introduction to the Access to Space for All initiative and HyperGES by my colleague Jorge Del Rio Vera. After that, we will be giving the floor to our partner, European Space Agency, for the introduction of the European Space Agency, ESTEC, and the Large Diameter Centrifuge facility and what you can do there. And after that, we will dive into the details of the announcement of opportunity and the application form. And as I mentioned earlier, at the end, we will have time for questions and answers. We are here today directly connected. If you have any technical questions to ESA, any administrative questions to UNOOSA, this is your time. Please don't waste time and ask us all the questions that you have. And with this, I'd like to give the floor now to Jorge to dive into Access to Space for All and HyperGES. Jorge, you have the floor.
Thank you, Hazuki. So let me share my screen. I hope you can see it now. So thank you very much for joining us today. It's really a pleasure to be here to talk about Access to Space for All and HyperGES. Access to Space for All is an initiative of the United Nations Office for Outer Space Affairs that aims at providing access to research facilities and infrastructure that otherwise are difficult to access or some countries don't have access to those. Also, we provide access to educational resources and tools. We cannot do that alone. We are doing that with the help of many partners. There in the figure, you can see the partners that we have. We have space agencies as partners, and we are very proud to be presenting today about HyperGES, which is a partnership that we have with ESA, the European Space Agency. There in the figure, you have also partners that are research institutions and universities, and we also have private sector entities also as partners. Basically, to provide all these opportunities free of charge. So the only cost that you are incurring in is basically, and that depends and varies from opportunity to opportunity, the generation of the experiment, the payload, the satellite, wherever the opportunity is aiming at. With Access to Space for All, what we try to do is mainly to build capacity, and to build capacity in an incremental manner. You will see that for that purpose, we have created different tracks that will help you to acquire that capacity from the start or from the ground to the orbit. It is an initiative that has a socioeconomic benefit and can foster job creation and actually employment of very skilled people. That is the people that actually is able to apply to these opportunities and to be able to, and is able to run experiments or to utilize those opportunities in a very good way, because the selection is based on merit. Also, it helps international cooperation. In the particular case of HyperGES, so the awardee team will be able to interact with experts at the European Space Agency, and will be able to interact with the colleagues here at the Office for Outer Space Affairs, helping to create a network that can help further developments in the institution that has applied. As it is an initiative of the United Nations, we cannot forget about 2030 Agenda for Sustainable Development and the 17 Sustainable Development Goals. And actually, you will be asked in the application form, and we will talk about the application form and how to apply to the opportunity later on, but you will be asked there the link between your application or your experiment and the Sustainable Development Goals. What we want you to do is to create these links, not at the Sustainable Development Goal level, the SDG level that you can see in the screen, which is very high level, but below that, there are targets and there are indicators. So we would like that you are focusing on the level of targets, which is one level below the Sustainable Development Goals. You can find information about the agenda in the links that are provided in the slide, and the slides will be available for you. In particular, access to space for all. In access to space for all, what we are trying to do, and I was mentioning that in the beginning, is to create capacity, so fostering quality education, so SDG number 4. Foster employment, so SDG number 8, decent growth and decent work and economic growth. And SDG number 9, industry, innovation, and infrastructure. And you can see the different targets in the slide that the initiative is contributing to. But that doesn't prevent that if you have an experiment that is devoted to, I don't know, to understanding plant growth in hypergravity conditions, that potentially have a link with SDG number 2, zero hunger, because you are trying to understand how the plant behaves better. So there are further links than only the ones that we are mentioning in this slide. That depends on the experiment that you're running. And for example, here you have some links to other SDGs. There were experiments that were run in microgravity conditions with another opportunity that we offer on the utilization of smart materials for and biocompatible materials in microgravity conditions to better characterize those materials. But there are other SDGs that the different experiments under access to space for all are contributing. There are some examples there in the slide. The initiative is structured on 3 tracks, which is what I was mentioning before. We are trying to acquire 3 distinct capabilities. The first one is the hypergravity and microgravity track, and HyperGES is part of this track. You can see it here in the hands-on component. And this track aims at building capacity to be able to run experiments in orbit. So you start from ground-based opportunities and you move through the different paths, I don't know if you can see the pointer, to orbital opportunities. Actually, ground-based opportunities, we have 2, a partnership with the European Space Agency on the utilization of the Large Diameter Centrifuge, HyperGES, and Drop Test, which is another partnership with DLR and CERN to test microgravity conditions. So actually, we are trying to cover all the spectra of gravity of levels of G. But we also have an education component that is giving you access to educational resources like webinars, this webinar that we are organizing, but also fellowships, workshop trainings, teacher guides, and different materials. And also we have a tools component that is basically providing you a list of open source tools that you can utilize for better applying to the opportunities that we offer. Then we have another track, which is aimed at basically building and operating satellites, which is a satellite development track. There you can see the structure. In this particular track, under the education component, we have a fellowship to study master's and PhD in a university in Japan. And we have that fellowship available. And we also have the tools component that is tailored to the satellite development track. And the last track that we have under access to space for all is the space exploration track, which is basically aiming at broadening the engagement in space exploration, with again the 3 components that you have seen in the other tracks. On HyperGES, and let's focus on HyperGES. So hypergravity and microgravity track, hands-on component. This is a cooperation, as I mentioned, with the European Space Agency. We started opening opportunities in 2019 under access to space for all, and aims at providing you access to a very unique facility that is hosted in in ESTEC, in the European Space Agency facility that is in Norway, in Germany, and in the Netherlands. And ESTEC stands for European Space Research and Technology Center. So that's where the most of space research and technologies happen at the European Space Agency. So you will be very well accompanied. The different experiments that can be run in the hypergravity and microgravity track are spanning over a full range of applications and full range of different fields. You can actually utilize hypergravity and microgravity experimentation to understand better biology, material science, fluid dynamics, physics. So it depends on your area of knowledge, the area where you might be interested in actually going to run one experiment or another utilizing the same facility. It's a very unique facility because it provides you with a wide range of G levels from 1 to 20, and you can accommodate in each of the gondolas that the LDC can host up to 80 kilos. So it's actually able to run very big experiments. What is provided in the opportunity is air tickets by the United Nations Office for the Space Affairs, and by the European Space Agency, you are provided accommodation and technical support. So it's a very interesting opportunity. And to know more about what you can do with the LDC and the work that you can do in hypergravity conditions, I leave to my colleague from the European Space Agency the floor. Thank you very much.
Thank you very much, Jorge, for the introduction on the Access to Space for All initiative and HyperGES. And with this, I would like to give the floor to our partner, European Space Agency, so Dr. Jack Van Loo. Yeah, Jack, you have the floor.
Thank you. I will try to share my screen. Can you see my screen?
Yeah, perfect.
Okay. Okay, thank you for the introduction, Jorge Azuke. My name is Jacques Van Loon. I'm actually from the Free University Amsterdam Medical Center, and also cooperating scientist at the ESA ESTEC Center in Noordwijk, the Netherlands. Some words about ESA. ESA started in 1975 with signing the ESA Convention, and that was signed between the first 10, let's say, founding member states, as you see them in this picture of Europe. Nowadays we have 22 full member states. It's still increasing though. ESA is distributed all over Europe, so you have facilities in the various countries where the headquarters is in Paris. The European Astronaut Center is in Cologne in Germany. ESTEC, where the LDC is in Noordwijk, the Netherlands. You have operations centers, you have a communication center in Redut, and another important one is the launch facilities in Kourou in French Guinea. This is ESA ESTEC picture. We are really at the rim of the Netherlands. Here you see some dunes very vaguely, and even more vaguely at the very top here. There's the North Sea. The subject of our discussion or lecture today is on centrifuge and gravity. And the centrifuge is located in this dome here, the center of gravity of ESTEC, of course. And I will explain you more about the facility. The whole lab where you see the dome again here, the whole lab where the LDC is located has different parts. You have the preparation lab, the gravity lab, where part of the ESA life support system developments are there, plant incubator. You have a big life sciences lab with incubators, flow benches, microscopes, clean room, which is not too much applicable for this, but this is where we work on planetary protection and cleaning instruments that go to Mars, for instance, or to other planets. We have a small meeting room and workbench you can make use of, a wet lab where we have the LCMS chemical detection technology, support lab where we have autoclaves, flow benches and chemicals storage. Picture of the facilities, the support lab where you have the chemicals, flow, fume hoods, pure water, milieu and demi water. The main lab, benches, centrifuges, small centrifuges, lab centrifuges, microscopes, incubators and flow benches, meeting room, the wet lab with some general instruments of balances and shakers and so on. Small workshop where we can make small adaptations to instruments if needed. If larger things need to be adjusted, then we can go to the main workshop at ESTEC. We have the preparation lab for the experiments in the LDC, and this is the LDC control room where you have here the computer for the for the scientist to monitor and control his or her experiment, and the system to really operate the LDC. And then we have some monitors to monitor what's going on in the inside the gondola. If we think about gravity-related research, then I think we should explore the full gravity spectrum. So going from nearly no gravity or microgravity all the way up to X gravity, and the X depends on what your experiment is and what you want to explore. So if we have 1G here, we have hypogravity, everything below 1G, and hypergravity, anything above 1G. And again, when you're interested in gravity, you should explore this full gravity spectrum. Making use of the LDC, the Large Diameter Centrifuge, you can explore anything above 1G, so you can see how your system responds to various increased G levels. That could be either a linear response with respect to gravity all the way down to microgravity, could also be some sort of exponential relationship to gravity. But again, if you're interested in gravity, I think you should explore the full spectrum. So these experiments you can do in the LDC, looking into hypergravity. You can also make use of the LDC, looking into a thing called the gravity continuum, where you do the experiments as I explained to you in the previous slide, but now you can make use of the data you generated in the LDC studies by extrapolating the data to learn about what might happen if you go to lower than 1G. Yeah, so you can extrapolate the data in a way that you try to predict what might happen if you go to a lower G environment, like on Mars or like on Moon, or even at microgravity, although that's a really particular situation where you have nearly no gravity at all. So anyhow, you can make use of the centrifuge to predict what might happen at lower G levels. Another way to simulate microgravity or simulate lower gravity is to make use of the reduced gravity paradigm. This is a regular microgravity, standard microgravity experiment where you are at 1G with your experiment. You're going to launch your experiment, then you are under microgravity conditions, and you have your microgravity response and adaptation time of your samples. This is what you expect in real microgravity conditions, real spaceflight conditions. What you might also do is to have your sample adapted to a high G level, for instance here to 3G, and then lower the G level to either 2G or 1G. And also here you have a reduction to this lower G and an adaptation time associated to it. And the hypothesis of the reduced paradigm is that these two changes, what you observe in the material, are similar. Not the same, but are similar. So also making use of this reduced gravity paradigm, you might predict in what might happen if you go to real microgravity situations. So again, you can use the centrifuge for regular hypergravity studies, for launch simulation studies, for parabolic flight hypergravity phase, and also for these gravity continuum and reduced gravity paradigm. So main features of the facility, in full swing out, it's 8-meter diameter. We have 4 arms on the system. We have various locations where we can locate the gondolas on each arm, 8 locations per arm. We have 7 gondolas, well, let's say 6 gondolas which are really rotating and 1 gondola in the center if you need to control for rotation. It's a swing out system, which means that the gravity level is always perpendicular to the floor. I come back to that in another slide. We can have a maximum of 80 kilograms payload per gondola, and we can go up to 20 times G. And the motor is 22 kilowatts. Each gondola is provided with these facilities. So we have a temperature sensor, we have analog digital channels for video, we have RS-232 channels, we have Ethernet channels, PoE channels for cameras, we have USB 2 and 3, of course power supply, fixation points if needed, we have gas and water supply lines and a forced ventilation system. So all this is available for each and every experiment in each gondola. This is a detailed setup of the electronics and connections between the various systems within either the rotating part of the LDC and the static part of the LDC. I don't go into detail. You find this information on the PDF that is provided associated to this meeting and later on the various websites of UNOOSA. More details can also be found in the LDC user manual, where you have a link on the bottom here. Again, this is to show that the resultant gravity factor when the LDC is rotating is always perpendicular to the floor of the gondola. So when you increase the speed of the LDC, the gondola will be, let's say, pointed more horizontal, but the G factor, the resulting G factor, will always be perpendicular to the G floor. When accommodating your experiment in the LDC and the gondola, make sure that you comply with the volume of the LDC and with the door dimensions of the LDC. So don't engineer it too tight, because that is difficult to get in or out. There is a base plate you can fix your experiment to if needed, but most of experiments do not need any fixation. And then you have fluid and gas containers you can store on the rotating part of the LDC. This is the typical spin up and spin down time of the LDC. It takes about 60 seconds to go from 1G up to 20G, and it takes about similar time to go from 20G to 1G. You can program this profile or any profile as you like. Here we have a profile for a Soyuz launch, for instance, but you can also have a parabolic flight profile, or any profile you want within the limits of acceleration you have for the system. For your experiment within the gondola, although there's a large diameter, 8 diameter meter system, there is still a G gradient depending on where you are within the LDC, and the best location for your experiment to be located is in the center of each gondola. So if you have a setup of your experiment, be sure that the sample you're interested in is closest or at the exact center of the gondola, both in horizontal as in vertical direction. If you deviate from that, you have small, because of the large diameter, deviations to the actual G level. It's not big, but if possible, try to locate your sample in the center as much as possible. Otherwise, you generate inertial shear forces, and again, you find a paper related to that in the bottom of this slide. Experiment capacity. We can have several gondolas on one arm, which means that we can have 2 different G levels running at the same time. So this one could be 20G and this one could be 10G. So you have a double capacity of your system in the same running time. We can use incubators on the LDC, so we can run experiments from about 4 degrees up to 40 degrees in the gondola. If you have a large setup, which needs, in this case, this is where the actual sample is, but it needs support electronics directly connected to it. I mean, we can put the other electronics in the nearby gondola, so you can run your full experiment. And then there's also a possibility to have your gondola, bring to the lab. Then you can easily work on it to set it up, and then when everything is set up, then we bring it to the LDC. Some examples of experiment configurations. Here we have an impact study where you see here some regolith, and here we have a projectile coming out. And then in this particular study, they studied the impact or the shape of the impact at different G levels for this projectile on this regolith. In this experiment, we studied the neurovestibular system of a crab. The crab is located here, again in the center of rotation. And we looked at the neurovestibular response of this crab at different G levels. Mass and heat transfer, the experiment is in the gondola, but we had these huge fluid containers to cool these experiments, during running. Planetary glacier, where we looked at the model glacier material, and we looked at how a glacier will flow at different G levels, again to understand how glaciers might respond in planets with a different gravity level than Earth. Bubble generation experiment, it's quite a complex experiment, and we needed 5 cameras to look at the sample and to adjust it if needed, so that was pretty intense. Here we have an experiment where we looked into the development of zebrafish, both at static G levels, but also in microgravity simulation, making use of the random positioning machine. And finally, an example of an experiment where we looked in cells, making use of fluorescence microscope, the EVOL 7000, in one of the gondolas, can go up to about 15 G, and the other experiment is to make use of a light sheet microscope, which he developed, where we can look at more 3D structures, with in a fluorescent system. So for the HyperGES proposal, what should be clearly addressed, at least from our point of view, is you have to identify why you want to use the LDC for regular hypergravity studies, for launch simulations, for low gravity extrapolations, or for microgravity simulations. That is a reduced gravity paradigm. Identify the science and applications background and rationale. So is there preliminary data of your own work or from references you should include? Also identify the duration of your experiment or the number of runs you want to do. There is a maximum of 2 weeks you can make use of the LDC. How to use the LDC, identify what parameters to measure and how, either online or post-exposure. Also identify the expected outcome, so the hypothesis of your system. How a preliminary hardware configuration is. I don't want to see any detailed engineering or components, but really an overview, what do you need, what is exactly required for your experiment, and can it fit both based on size and power or data configurations in the LDC. Think about the schedule and logistics, how to do things, how to transport things to the Netherlands, how to transport things back to your own lab. How to communicate your results, also very important. Of course, that there's a report needed, but also think about peer-reviewed science papers, conference presentations, and local and social media is also important. And also when providing a proposal, please check and recheck all the parts within the proposal, whether they are completed or not. This is a slide where you have, where we listed, let's say, papers that are published, peer-reviewed papers that are published based on work done in the large diameter centrifuge. So these are some general papers about centrifugation and background. These are papers on fluid physics, on cell biology, plasma physics, plant biology, animal physiology, geology and planetary science, technology and material sciences. So all these DOIs can be clicked and you'll find the paper related to that particular subject. So if you have any other questions or remarks, we can do that at the end of this webinar session, or you can always send me an email if you need any specific information. Thank you very much.
Thank you very much, Jack, for the really detailed presentation. His presentation is already on our website. I believe our my colleague Wenbin has put it in the chat. So make sure to download the presentation and look at all the different links that are provided on his presentation. Thank you very much, Jack. Now I'd like to give the floor to my colleague Jorge to go into the details of the application form and of course the announcement of opportunity. Before I give him the floor, everyone, if you have any questions, this is the time. We have ESA and we have UNOOSA connected here. If you have any technical questions to Jack, any administrative questions to us at UNOOSA, make sure to put it in the chat so that we can answer it for you. Okay, Jorge, please go ahead.
Thank you, Hazuki. Thank you, Jack. So let me again share my screen. So, I mean, what Jack was mentioning at the end is basically what we are expecting from you when you are submitting an application. We expect to know the why, the what, and the how. Why is relevant, hypergravity for your experiment, what you are trying to do and how you are trying to do it. There is a lot of people that is asking about why running experiments in microgravity. I think that the presentation of Jack was giving that very clear. But you also have included in this slide some articles that are related to biology and how the exposure to hypergravity environment actually affects how the plant biology behaves. You have changes in, for instance, in chloroplast size in a plant. You have changes in cell walls. You have actually changes in the root of the plant. So it's really interesting if you want to actually study how hypergravity is affecting a plant, and maybe those changes in hypergravity create some enhancement in the plant. You have a lot of bibliography that you can check. And the connection between this and the Sustainable Development Goals is pretty straightforward. There will be a connection between plant growth and Sustainable Development Goal number 2, zero hunger. So you see, it's not only the Sustainable Development Goals that I was mentioning before, there is much more that you can do. So let's get into the details. So how can you apply to the second round of HyperGES? How can you apply to HyperGES? So let me do this utilizing the browser. So if you go to the UNOOSA website, there are a couple of ways where you can actually go directly to HyperGES. One is here in the carousel. You have HyperGES. You actually click here and you are led to the website where you find all the documentation needed for application. Or, as I was mentioning before, it's part of Access to Space for All. Access to Space for All is a flagship initiative of the office, and you have their permanent placeholder that is linking you to the Access to Space for All main website. This is the main website of Access to Space for All. Again, if you want to stay tuned for news, and because we are opening opportunities and we are very active with the initiative, you find all the news in here. We are conducting interviews. We have the webinar that we are conducting today. For registration, it was there. Brochure on Access to Space for All, side events that we had, and the hypergravity experiments in the LDC. So you can actually click here and you are led to the web page of HyperGES, and also in the hypergravity and microgravity track, you have HyperGES down here. So you see there are multiple paths. All the paths are leading to the same place. So they are basically there to make your life easier depending on which page you are bookmarking. So for accessing the documentation, you either click here, HyperGES is now open for application, or you go to the rounds and click here, wherever you prefer. And here you have all the documentation. It's a little bit bigger so you can see it better. All the documentation is available there. Note a very important thing, that the deadline for submitting applications is the 18th of November 2022. But in this round, we are introducing something new, which is expressions of interest. And the deadline is approaching very, very rapidly, very quickly, which is the 31st of July. So you basically roughly have 1 month to actually submit an expression of interest. You don't need to submit an expression of interest to submit an application form, but it will help you in having a better application. So let's have a look at the documents. I would recommend you to have a look at all the documents that you have here, and not only the documents that you have here. As I mentioned before, we have other components that may help you actually getting additional information to have a better application. We conducted a series of webinars on hypergravity and microgravity. You have common webinars that are helping you to actually fill in the application form. So check out all these resources. We'll see in the application form, you will have a section on communication plan. And here you have a webinar that we conducted on how to raise awareness about your project. So check all this material. It will be very helpful for you. So back to HyperGES and back to the documentation. Let's start diving in the announcement opportunity. Announcement opportunity, I hope you can see it well. It contains all the information for you to apply. It will help you understand the opportunity, your duties, the responsibilities, and the information that you will need to submit and where to submit it. So first thing that you have is deadline, 18 November 2022. Application deadline is twice, well, actually 3 times in the application. So, there you have that. In terms of the people that is expected to apply, you have the information here, heads of research institutions or group who are a university institution, professor, or postdoctoral researchers with a team of bachelor, master, and PhD students. So we need a professor, basically, an academic supervisor, and a team of students. The team can be as big as you want, but as I was mentioning before, there is limited funding for this opportunity. And we can only fund up to 4 team members, including the supervisor. Can be funded by UNOOSA and ESTEC. So just take that into account. If you have a bigger team, that's fine, but be aware that we will not be able to cover the expenses for the flights and the accommodation. You have a description of the opportunity and the program. And something that is very important is eligibility criteria, which is, can you apply? Will you be eligible? Can we select you? So again, it's open to research teams from entities that are located in member states of the United Nations, with particular attention to developing countries. This doesn't mean that you have to be located in an institution that is in a developing country. What it means is that if there are 2 applications of equal quality, we will take into account the fact that one is from a developing country and maybe the other one is not from a developing country. So we'll try to promote the development of capabilities in developing countries with this opportunity. One thing very important that also leads to non-eligibility is you have to provide supporting documentation. One very important piece of documentation that you have to provide together with the application form is the letter of endorsement from your institution. The letter of endorsement is basically from the head of the institution saying that the institution is happy with the professor and the students applying for this opportunity. So just don't forget that you don't only have to submit the application form, you have the letter of endorsement, as it is mentioned in the section 12 of the announcement opportunity. How are we going to assess your application? Well, the criteria are defined here. These are the different criteria that we are going to take into account when evaluating your proposal. I mean, those were mentioned already by Jack. Why do you need hypergravity? Why are you using the LDC? But also there are the criteria like how is that experiment represented in the syllabus of the student, or how are going to be or what are going to be the activities that you are going to make to take for communication and dissemination. And as I mentioned before, linked to Sustainable Development Goals. So you see there are a number of criteria here. Something that you can do is actually here in the documentation, you have the evaluation table. So you can see the way we are going to evaluate your proposal. So you have all the information for an eligibility criteria point of view, and also the different criteria that you have seen in the announcement opportunity are represented here, and they have their different weights. So have a look at this and be sure that you are working hard to get your the highest score that you can get. All the information is available there. So back to the announcement opportunity. So we have the selection criteria, as I mentioned. You have a lot of reference documentation. The reference documentation is listed in the announcement opportunity, but it's also in the website that I was showing you before. And in this cycle of HyperGES, we have something that is very special, which is technical consultation, to basically to provide feedback and advice to you on your ideas. Maybe you have a very good idea, but you don't know very well how to change or how to make it from the idea to the application form. Don't worry, we are here for that, and we will provide you a technical consultation session to actually help you in doing that. Technical consultations will be of 1 hour, and we will have them from now until October. So what is happening now? The opportunity is open until the 18th of October. The expressions of interest are open until the 31st of July. So it's helping in the application phase. After the application phase is completed, we will be running the selection for a couple of months to be able to select the team that will be awarded the opportunity. And then you will have a preparation time of your experiments of 7 months. When you are now at the stage that we are, you don't need to have your experiment ready. You just need the idea, be able to conceptualize your idea in the application form, and then you will have enough time to actually prepare your experiment. You don't need to have an experiment ready at this stage. Then you will have up to 2 weeks to run your experiment in the LDC, and then after that, you have to produce a report that will help us understand how well and how useful was the experiment for you. After that, of course, you will be publishing your results in different journals and papers. And under the Access to Space for All initiative, we have our D pages that are devoted to the different teams that have been awarded the opportunity. Those pages are for you. So basically, whatever information you are providing to us, even if it is 4 years after the opportunity have closed and you have run your experiment, we will be updating the award web page with elements that are relevant to the experiment that you conducted. I mean, sometimes, let's imagine that there is a student that is starting a PhD and is utilizing this opportunity to gather data. PhD will be ready in like 3 years' time or 4 years' time. So that's a result that will only materialize after a certain amount of time. So we are happy to include that in the awardees page. Then you have where is it provided. As I mentioned before, we are providing air tickets. ESA is providing technical support and accommodation, and you are putting the experiment. So you have to cover the cost for the preparation of the experiment and any derived costs that are not covered by UNOOSA or ESA. For expression of interest, as I mentioned before, 31st of July. This is the email address for expression of interest. And then we will be discussing with you when to have technical consultation. We'll coordinate also with the European Space Agency for that. And then for the application form, and we'll talk about the application form in a second, you'll have until the 18th of November. Again, it's the same address, but remember that you have to send at least 2 documents, the endorsement letter and the application form. So that's basically, in a nutshell, the information that is contained in the announcement opportunity. I invite you to read it very carefully because all the information is useful for you. The better understanding you have of that, the better is going to be your application. Expression of interest, which is the novelty that we have in this application round. So expression of interest is basically 1 page. And what we want you to write in there should not exceed 1 page. We want to keep things simple for you. And there are 2 parts in this document. Basically, the part that is devoted to whoever is submitting the expression form, the interest form. So details about the person, the affiliation, the institution where the person is located. And here we have space for 2 or 3 paragraphs about your experiment, or the experiment that you want to do. Again, what we are looking for is for the idea. What you are trying to do and what you are trying to achieve and why you are trying to achieve that. Maybe you have a lot of questions. Maybe you have doubts. Maybe you don't know how to implement that. That's fine. This is why we are doing this. Utilize the box that is below for your questions or your comments. So when we are getting this document from you, we know which is the way to help you. Maybe you have questions on particular sections of the application form. Maybe you have a big question mark on the full application form. We'll discuss that during the technical consultation. And please provide us some guidance on what type of information you will need during the technical consultation, utilizing that box. Anyway, we will be discussing with you for the organization of the technical consultation. So if we need more details, we will ask you for those. And I will repeat it again. You have until the 31st of July for doing that. It's a great opportunity. It was never there before, so take advantage of it. That's my advice. Oops, sorry for that. Then let's dive in the application form. The application form is a document that is a little bit more comprehensive. It's longer. It has like 17 pages. Make it a little bit bigger. And there are 2 types of sections in the application form: mandatory sections and optional sections. Optional sections, if you have the information, provide it to us. If you don't have the information, don't provide it to us. Just mark TBC to be completed, to be provided at a later stage. You have instructions in here on how to complete it. And let's go to the abbreviations and references. Please provide us information, the definition of your abbreviations. Sometimes it's very difficult to read a proposal that has, or an application that has a lot of abbreviations, because the space sector and each different scientific field has different acronyms, and sometimes they are the same acronym for different things. Then a very important part for us, just to understand a little bit better how you got to know about the opportunity and which type of institution you are, is there project title and executive summary. This executive summary, we get that question very often, is the executive summary of the entire application. So you write that at the end. When you have all the application completed, you write the executive summary summarizing your application. It's helping us to understand what comes after, which is the complete application form. Then we have this page, which is the certificate. Again, we are asking for the letter of endorsement of your institution, plus certificate. The certificate has signatures, so normally you will scan the original one. You need signatures of the project coordinator, and the project coordinator needs signature from the head of the organization that is applying. Here you can see that there is a signature of the head of the organization and also the seal of the organization. In case this is a collaboration of more than one entity, one organization, you have space for another one. And if it is free, it's fine. I mean, you just replicate that field. Of course, it's complicated that for an experiment that we are funding only a reduced team of students, that there are many organizations, but it can happen and it's fine. No worries with that. Yeah. Here you see head of applying organization information and mandatory field. Again, if you have more than one, just repeat this section as much as needed. You have a description of what is needed in each section. So this description is there to help you, providing us the information that you need to provide. So just read the descriptions. If there is a cooperation, several entities, that's why this is optional, because it might be that it's not. You have to describe the role and responsibilities of each of the entities. So the project coordinator is only one, and team members. And again, repeat this section, because there we have only the box for one team member. You will. In case you have some external support, you are working with a, let's say, a private company or another institution that is providing you some support during the project. So you can write it here. Maybe there is a private company that would provide you some supplies to actually produce the experiment. So just list that external support in there. It's not an applying organization, because private companies will not qualify for eligibility. And if you put a private company as an applying organization, you will be not qualified for selection. So you will not be eligible, so don't do that. But you can list that organization, that private company that is providing you some support under external support. That's totally fine, and there are no problems. Then proposal abstract. So describe your experiment. It's basically your experiment, the rationale, the why, the what, and the how that we were mentioning before. Again, it's a summary, so we understand also what you want to do with the experiment. Is your research hypothesis, how you are going to contribute to capacity building. You see, all these are M fields, mandatory fields. Which are your objectives that you would like to achieve with the experiment that you are going to run? Relevant to the Sustainable Development Goals. Remember that this is a selection criteria. So you basically click there, you are led to a page, which is the web page of the Sustainable Development Goals. And in there, you scroll a little bit down. Oops. You will open eventually. Yes. So if you scroll a little bit down, you have the 70 Sustainable Development Goals. If you click, we were talking before about zero hunger. If you click on more info, it basically a web page will open. We will provide you additional information about the Sustainable Development Goal number 2. You will have some facts and figures here. But very important for you is the web page that is listing the targets and indicators, because a good application will not link to the Sustainable Development Goals level, will link to the target level or even the indicator level that is there. So just take that into account when you are preparing your application for. Which are the outcomes and deliverables that you are going to be producing. So it's capacity building, but we want you to be forward-looking. What is what you are going to do after? Which are the potential, the possible evolutions of your experiment? Which is the novelty that you are bringing by running the experiment that you want to run in the LDC? All that information is to be captured there in no more than 150 words. Work breakdown structure is how you are going to distribute the different tasks that you will need to do among the different team members, or if you have different organizations, among the different organizations. Requirements that you will have for your experiment that you will need to fulfill when you are preparing your experiment. You have for that two very important documents, which are the LDC Experimental User Manual and a website on technical constraints on the LDC. That information is available here, LDC User Manual, LDC Technical Constraints. There is even more here. You have examples of past experiments and a summary of the LDC and also webinar materials, the series that I was mentioning before. So check all the materials that are available for you. They are going to be extremely useful when you are preparing your application form. Then we go to the experiment specification and description. You have to provide us some basic information, which is main estimated specifications, estimated, underlined, because you have not built it yet, right? And we want this to be sure that you are not exceeding the capabilities of the LDC. For instance, before Jack was mentioning that each gondola can accommodate 80 kilos. If you have an experiment that you estimate that is going to weigh 120 kilos for a gondola, it's not going to work. We have to know that. That's why we have this table here. Also, the dimensions are there. Then you have optional. So if you have technical drawings, because you are very advanced in your design and you're already starting to draw it, provide the technical drawings there. If you have external dimensions, of course, if you have the technical drawing, you will have the external dimensions. And if there are any protruding objects, you can provide it there. If not, it's fine, it's optional. You will need to test your design, your experiment design, and you will need to assemble it. So please provide us a description of what those are. Typically, that is happening in the labs of university or research institution that is applying. So just explain us a little bit about that context and which are the equipments that are available for you for this particular experiment. That will be very helpful. And how you are going to verify that it's going to work. You install it in the LDC. Then we need to understand your development schedule. As I was mentioning before, you have 7 months for the whole development. After that, you have to run your experiment. So we want to understand your development schedule. The experiment schedule, the only thing that we are asking you is to confirm to us that you are going to be able to run it in 1 or 2 weeks, which is the maximum time that you will be allocated to LDC. In terms of budget, I mentioned what is going to be provided with this opportunity, but you will have to cover the cost of the development of the experiment, right? And maybe transportation cost and shipment. And if you have extra team members that are not covered by the opportunity, you may have to pay the travel cost for those. So we want to understand which is the cost for you. And we want to understand how much of that cost is secure and what is the plan that you have to actually secure the rest. So we understand basically the feasibility. How you are going to transport it to the Netherlands. We want to be sure that you have at least have a look at different elements related to the transport, like custom arrangements. Maybe you have a weird material in your experiment and that has some import-export restrictions. So just have a look and be sure that you keep that in mind. Then what I was mentioning before about feasibility. So cost is part of the feasibility and having a budget plan is part of the feasibility, but there are other elements. I mean, maybe your experiment is so novel that it's going to be the first time and there is very basic, there is very little research prior to that. So maybe there are some risks associated to that, and that may jeopardize the feasibility of the experiment, or maybe not. And you explain to us that it's going to work. So these 2 sections are basically to tell us about the feasibility, how feasible it is, and that you have analyzed the different elements that are contributing to a feasible experiment, and you have examples in there. And again, a risk analysis. I mentioned before, communication and dissemination plan, again, mandatory. Please, please, please utilize the webinar that we have for that. You will boost incredibly your communication and dissemination plan. So for that, as I was telling you before, common webinars, there you have a lot of things that are common to all the opportunities that we have. And you have how to raise awareness about your project. I'm sure that my colleagues will put the link to this exact webinar in the chat, so you will have it there. Have a look at that because that's important for for actually building a consistent code. And the last section of your application is the supporting documents. We don't want that you are providing all the supporting documents within the application that you are submitting. We just want here a list. You can provide many files, no worries. You provide here a list so we can check the list against the documents that you have provided. And it's basically a safety measure, because if the list has more documents than what you have provided, we can go back to you and say, hey, you are missing a document. And it's also helping you in cross-checking that you are sending to us all the documentation that you are intending to send to us. So just a list. It's written very clearly here. So please don't provide all the documents inside. Please attach those documents as separate files. So again, instructions are very clear. You just need to read the instructions. And I think that's all what I wanted to say about the application form. Again, if you have questions, chat is available. Back to you, Hazuki.
Thank you very much, Jorge, for the detailed presentation. I know this is a lot of information for everyone to digest, but all the documents are on our website. Please take your time and read all the documents. One question I see from Madhavan, thank you always for joining us. Are there any topics of interest from the UNOOSA side? Maybe I can give this question to Jorge. I would say we're interested in basically everything, because we are really, as Jorge explained, we want to reach all the SDGs. So not just the ones that we mentioned earlier, which is 4, 8, and 9, but we would really like to reach more SDGs, and the applications, the projects that all the applicants will bring in will help us expand that. But yeah, Jorge, do you have any comments on anything from us?
No, not particularly. I think, I mean, this question is relevant to also ESA. What we want to see is that you experiment what is interesting for you and what is relevant to your studies. I mean, if it is a team of students that are preparing the experiment, so you just think whatever might be useful and needs hypergravity to conduct your research. Any application that is fulfilling those requirements is fine for us. The topic space is the limit. One thing that I can actually offer, I don't know if Jack would like to complement what I just said. I think
Oh, sorry. Yeah, my phone was muted. No, it's okay. I mean, it's the main point in the application is it has to make sense to identify in your proposal why gravity would be of help with the question you have. Yeah. And that could be questions related to materials, could be questions related to cells, mammalian cells, could be questions related to plants, could be questions related to fluids. That doesn't matter. As long as it makes sense, we have to have a good understanding in why you need to expose your sample to a higher G levels to be able to answer some questions you have.
One question coming in. Can the application be accepted where one has asked for funds and considered unsuitable? So regarding the funding, as Jorge explained, it's written in the announcement of opportunity. UNOOSA will be funding for the tickets for the 4 team members and the 1 professor that will be supervising the team, and ESA will be providing support on the accommodations. So if you are asking for more funding regarding the travel and all of that, that would not be available. We only will be able to fund 4 people, 4 students, the student team, and of course the supervisor. Jorge, would you like to add about this point?
I mean, just a very little clarification also. I mean, the funding that we have allocated to this project and that ESA has allocated for the project is for covering the expenses that Hazuki was mentioning. Maybe the issue that you have is not to be able to cover the cost of your experiment, which is on your shoulders. So what we were asking you, if you have been considered suitable for a potential funding source, I mean, there are more, so don't despair. We need to understand what is the cost of your experiment and which are the actions that you are going to undertake to acquire that funding later on. And we have seen very creative proposals, and we have seen people very successful in, for instance, running crowdfunding campaigns and talking to the dean after having very strong possibilities of being selected. So just don't hesitate, provide us the cost, provide what is the budget that you have, what is your budget plan, and with that information, we'll try to assess and potentially select your application.
Thank you very much, Jorge, for the follow-up. Does this person have any more additional questions related to that? Of course, you can always email us at the email address that one been provided earlier, UNOOSA@un.org. Okay, I don't want to take too much of your time, so thank you very much. And as I said, the deadlines, you still have time for the deadline, so I hope that you will all be sending us your application forms and of course your expression of interest. Thank you very much, everyone. Take care and have a nice day. Bye.